So first we will create a class. Here I will create a class, some sample. This class contains static variables. Static int a is equal to 10 and static int b is equal to some 20, and this class contains non-static or instance variable. Int x is equal to 30 and int y is equal to some 40, and this class contains main method public static void main string array args. This is my main method. Inside this main method, I will create local variables. Int p is equal to, inside this main method, I will create local variables. Int p is equal to 50 and int q is equal to some 40. Q I will give as 60. Next I will create this sample class objects. Some sample s1 is equal to new sample and sample s2 is equal to new sample. I have created two sample class objects. So this is my class. So this is my sample class. Now I want to see how this sample class will be executed inside JVM in our runtime data areas, how this class and these variables and these methods and these objects will be created, where it's stored, how it is created. I want to see everything internally. Don't worry, I will show you how it works internally. Here we will create JVM architecture. This is my JVM architecture. This inside JVM architecture we have 5 runtime areas. What are those? We have method area, and heap area and Java stacks area and we have PC registers and we have native method stack area. This is my method area. This is my heap area. This is my Java stacks area. This is my PC registers area. PC registers area. And next we have native method stack area. Native method stack area. These are the runtime data areas we have inside JVM architecture. So what happens when we execute this sample class? Now I have successfully compiled this sample class. I am executing this sample class by using command called java sample. After executing java sample command, what is happening? My method area is searching for my class sample. How? When we run this sample class, my Java launcher will create JVM as a process. When this Java launcher created JVM as a process, all this we have discussed in our virtual machine. A process will be created. So once JVM setup is completed, my JVM will search for my sample class bytecode in my method area. But since our sample class bytecode is not found in my method area, then my JVM will request class loaders. We have discussed we have three types of class loaders: bootstrap class loader, extension class loader, and class path class loader. All those class loaders. So JVM will request class loader subsystem to load my sample class bytecode into JVM in method area. And our app class loader, which is class path, we have given class path for in our environment variables. Then app class loader, which is class, or we can call it as class path class loader, will load and will store my sample class bytecode inside this method area by creating java.lang.class object. After bytecode verification is completed, in preparation phase, memory will be allocated for. After bytecode verification is completed, in preparation phase, memory will be allocated for my static variables which I have written in my sample class A and B. Means A and B in their class context in method area, means in preparation phase memory will be allocated for this static variables A and B in their class context in method area with default values. What is the default value of our static int A variable A, static int B variable? 0 is the default value. That 0 will be stored after bytecode verification. Then In initialization phase, first I will show you how it will create. So one java.lang.class instance is created. Java.lang.class instance. One java.lang.class instance will be created. Then after bytecode verification is completed, in preparation phase, memory will be allocated for this static variables with default values. How? This is my sample class memory. Inside this sample class memory, first it will allocate memory for my static variables with default values. For A and B, it will allocate memory for my static variables with default values. What are the default values? 0 is my default value. 0 will be stored inside A and B. So after allocating default values to my static variables, then it comes to initialization phase. In initialization phase, my static block will be executed. I did not write static block, but I have written static variables. The static variables will be executed in thread by using static block. I will show you how it is executed. So in initialization phase, static block is executed by creating a stack frame. It will create a stack frame inside main thread in Java stacks area. In Java stacks area, main thread will be created. This is my main thread in Java stacks area. Inside this main thread, it will create a stack frame inside this main thread. This is my stack frame. Inside this stack frame, it will execute my static block. What is there inside my static block? Since I did not write any static block in sample class, our JVM will create static block. Inside that static block, it will create memory for my static variables. I have written two static variables. The static variables will be initialized by using static block inside my JVM main thread. A is equal to 10 and B is equal to 20. These variables will be initialized inside static block in main thread. So you will get a doubt like what is stack frame? You will get a doubt like what is stack frame? Stack frame is nothing but whenever we have methods and blocks in our class, whenever we are calling some methods for example, in my main method, if I have m1, m2, m3, some m4, I have four methods. I am calling those four m1, m2, m3, m4 methods from my main method. Then internally what happens means inside this Java stacks area, it first main thread will be there because I am writing main method. This Java stacks area by default will create two threads. By default, Java stacks area will create two threads. It is created by Java stacks area itself, main thread and garbage collector thread. What this main thread will do? What this main thread will do means main thread will execute our class by starting execution from our main method. It will execute our class. This garbage collector will destroy the memory for my class after execution is completed. So let's come to discussion. What is stack frame? Stack frame is, for example, I have m1, m2, m3, m4 method. Four methods in my class sample. I am calling those four methods from my main method. Then what will be happen internally? So for inside main method, I am calling m1, m2, m3, m4 methods. When control came to main method, inside it will find that I have called m1, m2, m3, m4 methods. When control came to this m1 method, for every method which I have called inside main method, it will create a stack frame. For m1 method, it will create a separate stack frame. For m2 method, it will create a separate stack frame. If I use any block, either it is non-static or static block, for different blocks, either it is static block or non-static block, it will create a different stack frames inside a main method. Means our stack frame is a sub block of our main thread. For every method, for every block which you have writing inside a class, for every method, for every stack, for every method and every block, one separate stack frame will be created. That will be executed inside Java stacks area main thread. So now I have main method inside my sample class. For this main method also, one stack frame will be created inside main thread. This static block execution is completed. My static blocks, my static variables a and b, which is having zeros, will be initialized with their values. This 0 is initialized with a value which is having 10, and this b value is initialized with value 20. And next, after initialization, in execution phase, main method logic is executed by creating separate stack frame in our main thread. In main thread, another separate stack frame is created to execute our main method logic. Main. This is my another stack frame, string array. I have already explained you for every method which we are calling, for every block it will create separate stack frames inside main thread. Stack frames are sub blocks of our main thread. So it has created a stack frame inside main thread for my main method execution. And I forgot to write this instance non-static variables and main method and static block. I forgot to write in this method area because in the initial lectures we have discussed when class is loaded all the data will be stored inside method area. So what will be stored here? Static variables and non-static variables all the data will be stored in method area. My x variable and my y variable. My x variable and y variable will not get memory inside method area. Why? Since our first class itself we are discussing non-static variables will get memory when object is created. Since I am explaining you execution flow, in our execution flow we did not create sample class object. We have two sample class object, but we did not come to that step. I am explaining you step by step what is happening. When this variables will be initialized, we will discuss step by step. But for till now what we have discussed, x and y variables will not be initialized because we did not create, our JVM is not created sample s1 and s2 objects. We will come to that point. So in method area, what data will be stored? We have data like, and we have main method inside sample class. Main string array and static block. Static block will be placed default by JVM to initialize static variables with its values which we have assigned. So this is my data which I have in my sample class in method area. Next we will come to discussion. So this initialized data will be assigned to my variables. We have discussed about this point. Next we will discuss about main stack frame. So after initializing my static data from my static block to static variables, I have initialized 10, 9, 20. Then after initialization in execution phase, my main method logic is executed by creating separate stack frame inside main thread. We have created a separate stack frame inside main thread, and static variables are initialized with assigned values 10 and 20. Once after static block execution is completed, this stack frame will be destroyed. And after initializing in execution phase, my main method logic is executed by creating a separate stack frame in main thread. And after initializing my static block variables which I have, a is equal to 10, b is equal to 20, after initialization in execution phase, main method logic is executed by creating separate stack frame. I have created separate stack frame in main thread in Java stacks area, and inside this main method stack frame, its parameter args and local variables like we have p, q and s1 and s2 memory is allocated in this main stack frame. In this main stack frame, first it will create parameter args, some args, with some address like 1111, and this address is pointing to a object which is created in my heap area, which is having length. By default, my string length is 0. 0 will be stored inside this memory. This is my parameter arg. Next, what will be happen? My non-static variables will get memory by creating objects S1 and S2 inside heap area. In heap area, one empty string array object is created. I have created a empty string array object, and now I will create two objects of sample class, and non-static variables x, y memory is allocated in heap area in their objects. We will see now. My non-static variables are p and q. Which is having values as 50, and q is having 60. 60 will be stored inside q. Next, it will create memory for my S1 and S2 objects reference. This is my S1 object reference, and this is my S2 object reference. And this reference is pointing to my heap area objects. I have to create two objects inside heap area because my sample class is having S1 and S2, two sample objects, S1 and S2. This is having address sum 1111. This is the address of string array parameters, and this S1 object is having some address 1010, and my sample class contains some non-static or instance variables which is x and y. This x and y will be stored inside my two sample objects because we have created two objects for sample class. That's the reason two copies of non-static variables memory is created. If you create 100 objects of sample class, all the non-static variables data will be stored inside that 100 objects because non-static or instance variables will be initialized when object is created. X and y. X value will be initialized with 30, and y value will be initialized with 40. So this p and q are my local variables to my main method. Already in main stack we have local variables p and q. This p and q will be destroyed when my main method execution is completed. Now I have one more object. This is my s2 which is having some address 2020. Inside my s2 objects also non-static or instance variable data will be there. .30 will be stored inside this. .40 will be stored inside my y. Each object will be having all the data of non-static variables, because non-static variables will get memory when object is created. If you create 100 objects of sample, all those 100 objects of sample will be having non-static variables memory. So this S1 reference contains my S1 object address. This address will be stored inside S1 reference, and this will be pointing to my 1010 object, and 2020 address will be stored inside my S2 reference, and this S2 reference is pointing to my S2 sample S2 object. This is how my Java class will be executed internally, and one PC register will be created. Why this PC register will be created? One PC register will be created with some MPCR. What is this MPCR? This is my main thread PC register. What this PC register is doing? This PC register, which is created inside JVM, will monitor my main thread. PC register is nothing but whatever the threads you are creating inside Java stacks area, for each thread, one PC register will be created to monitor the threads. It will be monitoring the threads, what the thread is doing, and it will monitor the thread execution flow. This is the working procedure of our PC registers. And native method stack area, we have discussed, it is used for, it works internally for native methods which we have written in our class, whatever the C program or any program that will be executed inside native method stack area. Since we don't have any native methods, that's the reason native method stack area will not be executed we don't have any logic related to native method stack area. This is how our class will be executed inside JVM architecture. So I think we have seen this type of classes executing in our command prompt. We have executed so many classes. That's the reason I am explaining to you how this class is executing internally. So this is the internal execution process. And once this main method execution is completed, like in my class main method execution is completed, then its stack frame which is created, my main stack frame will be destroyed, main thread is destroyed, and sample class is unloaded, and JVM is also destroyed. And in PC registers area, one PC register is created for tracking main thread execution. I have already explained to you. PC registers, one PC register is created for tracking, for monitoring my thread. For each thread, one PC register will be created to monitor that thread. This complete execution is tracked by my execution engine, one of the JVM component we have discussed in our JVM components. Execution engine is tracking my complete execution. So this is about execute our Java class execution internal process.